So how do we divide rational expressions? We have to multiply the first term by the reciprocal of the second term, and you already know this from 6th and 7th grade, where we called it keep, change, flip. And we have to check for domain restrictions from both denominators and the numerator of the second fraction. That is very important, and you will see in a second how this works. On to our first example. So we keep our first fraction, we change division into multiplication, and we flip our second fraction. And now we have a multiplication problem. Let's write everything in one fraction and order our terms around. Now we can see if we can simplify anything. 5 goes into 15 3 times. 8 and 12 have a common factor, which is 4, goes into 8 2 times, and into 12 3 times. Now we have 3's in the numerator and the denominator that can cancel each other out. Our x to the 5th power divided by x squared. Subtracting the exponents, we are left with x cubed in the numerator. So our final answer is x cubed divided by 2. And that's it. Now let's look at the domain restrictions. We need to check both denominators and the numerator of the second fraction. And that is, of course, because as we rewrite it as a multiplication problem, we flip the second fraction, and now our 15x squared is in the denominator. So from the original denominators, we have no restrictions, but obviously x cannot be 0. Otherwise, 15x squared would turn to 0. And here are all of our restrictions. Okay, on to the next example. And again, we're going to rewrite this as a multiplication problem, but also let's not forget to factor whenever we can. Our denominator, x squared minus 1, is again a difference of perfect squares. So we can rewrite this as x minus 1 times x plus 1. And that fraction gets multiplied by x plus 1 divided by 3x. Now we can simplify by canceling out the 2x plus 1's, and we can also cancel out the x in the denominator against the x squared in the numerator, and only an x remains up there. So we are left with x divided by 3, let's not forget the 3 from here, times x minus 1. Domain restrictions, there are some. This is what we have to look for domain restrictions, and remember our x squared minus 1, we also factored this out. So x cannot be equal to 1, comma, negative 1, or 0. Let's move on to the next example. Let's first have a look if we can factor anything. The numerator of our first fraction, x squared minus 9x minus 22, can be factored into x minus 11 times x plus 2. Checking our denominator for target sum and target product. Our target sum being negative 25 and the target product being 66. We realize that we also can factor this with the two numbers negative 22 and negative 3. But since we have a coefficient that is not 1, a is not equal to 1, we have to split the middle term. So let's go ahead and do this. 2x squared, you can do that in the left margin of your note page. 2x squared minus 22x minus 3x plus 33. Now factor by grouping. 2x squared and negative 22x have 2x in common and are left with x minus 11. And negative 3x and 33 have negative 3 in common and are also left with x minus 11. Remember, the two negatives turn the 33 positive. So our two factors are 2x minus 3 times x minus 11. And that is exactly what goes into our denominator. 2x minus 3 times x minus 11. And that gets multiplied by the reciprocal of the original second fraction, 2x minus 3 divided by x plus 2. Now let's go ahead and cancel stuff out. There's a lot to be cancelled out. X minus 11 can be cancelled out. X plus 2 can be cancelled out. And 2x minus 3 can be cancelled out. Look at that. And our answer is nothing other than 1 over 1, or in other words, 1. However, we do still have domain restrictions to consider. And again, we have to look in all these three expressions for domain restrictions. And therefore, our domain restrictions are x such that x cannot be equal to positive 3 halves, positive 11, positive 3 halves again, but we already have that, and negative 2. Here are our domain restrictions. Let me redo these braces. Here we go. In our last problem, we only have to be a little careful to sort everything out properly. The rest is just like we did it before. So our first term, let's give that a denominator to make sure that we realize what we're actually multiplying with what. Also, let's look at our trinomial, and we see that we can achieve a target sum of 1 and a target product of negative 30 with the numbers 6 and negative 5. So we can factor this into x plus 6 times x minus 5. That term gets multiplied by the reciprocal of the second fraction, which we also have to check for factoring. Our new numerator, x squared plus 7x plus 12, can be factored into x plus 3 times x plus 4. Our denominator, x squared minus 11x plus 30, can be factored into x minus 5 times x minus 6. And we bring along our third fraction unchanged because that was a multiplication problem all along. And again, lots of stuff to simplify. We have x plus 6 that can be simplified, x minus 5, and x minus 6. And we are left with x plus 3 times x plus 4. Now, let's look at our domain restrictions. Domain restrictions, again, we have to look for in this entire fraction, but also in the denominator of the last fraction. So, x such that x is not equal to 5, 6, negative 3, negative 4, and negative 6. And that's all of the main restrictions. Here is our final answer. And that's it for today, and I will see you in class.